Hi students, this is we are going to look on the chapter in organic chemistry paper, the first unit, UV visible and IR spectroscopy. Here we are going to discuss about the UV visible spectroscopy first, and so for that we have to know the basic idea about the spectroscopy. So what is spectroscopy? I think all you know about the spectroscopy. What is spectroscopy? Anyway, I think in your third semester, means in a previous semester, you gone through the spectroscopic chapters. So spectroscopy is the branch of science that deals with the study of interaction of matter with light, or otherwise we can say it is the branch of science that deals with the study of interaction of electromagnetic radiation with the matter. Interaction of matter with electromagnetic radiation deals with the study deals with this interaction is known as spectroscopy. So first of all, we have to know what is electromagnetic radiation. This electromagnetic radiation means it consists of a discrete packet of energy. That discrete packet of energy is called as photons. That photons means electromagnetic radiation consists with the electric field and magnetic field that are oscillating with perpendicular to each other. This electric field and magnetic field are oscillating, but that are in a perpendicular direction. We can see here it is that is the if it is a magnetic field, it is the magnetic field. So it is the electric field, and see that these are oscillating. This electric field are oscillating and also magnetic field are oscillating, but that both are in perpendicular to each other. Then, while considering the electromagnetic radiation, the fundamental terms we have to know that the frequency. What is frequency? It is defined as the number of times electrical field radiation oscillates in 1 second. You can see that these electromagnetic or electric field and magnetic field are oscillating. So, for considering the electromagnetic frequency of electromagnetic radiation, it is the oscillation of this electromagnetic radiation in 1 second. It is the number of times electric field radiation oscillates in 1 second. Electrical field oscillation in 1 second is known as frequency. The unit of frequency is hertz. Then the next term which we have to know about the electromagnetic radiation is the wavelength. What is wavelength? It is the distance between two nearest part of the waves in the same phase, that is distance between nearest crest or trough. You know that it is the crest and it is the trough. So the nearest trough distance is known as wavelength, or nearest trough distance is known as wavelength. Then wavelength, here you can see that this is the wavelength. What is the relation between wavelength and frequency? Is C is equal to nu into lambda. As photon is subjected to, we know that photon is a discrete of energy, so it is related to energy. So E is equal to h nu. From the relation we know C is equal to nu into lambda. So here nu is replaced by h into C by lambda. So frequency and wavelength. Then next is the amplitude. Amplitude is the nothing but that wave height, trough height or peak height. And these are the electromagnetic radiation and spectrum. Electromagnetic spectrum. It consists of 7 things. Means gamma rays, X-rays, ultraviolet, infrared, microwaves, radio. This is the visible, and these are the visible region. That is, you can see that here, and we can see more about this visible light. If the visible light is passing through the prism, you can see that will be a splitting of this visible light. That is we termed as a Vibgyor, and see that visible light spectrum. Okay. Then what is the principles of this spectroscopy? Spectroscopy is based upon the principle and the measurement of spectrum of sample containing atoms or molecules. And this sample means any types of compounds that will contain atom or molecules, and its measurement is known as spectroscopy. That measurement is sometimes the intensity of absorbed or emitted radiation. The spectrum is the graph of intensity of absorbed or emitted radiation versus frequency or wavelength. That spectrum is based upon the intensity of absorbed or emitted radiation versus frequency or wavelength. The spectrometer is an instrument that will designed to measure the spectrum of the compound. And then we know that spectroscopy and spectrum, that is sometime will be absorption due to the absorption or emission. This absorption is an analytical technique which concerned with the measurement of absorption of electromagnetic. Sometimes the material is absorbing the electromagnetic radiation, then we are analyzing that absorbed spectrum is known as absorption spectrum. Means and UV visible is a spectroscopy, absorption spectroscopy, IR spectroscopy also a absorption spectroscopy. What is emission spectroscopy? Here is the emitted spectrum we are analyzing. So that is the example for this emission spectroscopy is mass spectroscopy. Then the interaction of this electromagnetic radiation with matter is known as spectroscopy. So what is happening there while the interacting with the electromagnetic radiation with matter? First of all, the electronic energy levels. We are considering about the electronic energy levels. This electromagnetic radiation matter contain different energy levels, electronic energy levels, vibration energy levels, rotational energy levels, like etc. So electronic energy levels, we know that all the molecules at a ground energy state, all the molecules at room temperature will be at the lowest energy level. That is mean the high ground energy level. If it is absorbed by UV visible light or any other electromagnetic light, what will happen? It will jump from lower energy level to higher energy level. That energy difference will be equal to photon h nu. That will be equal to En minus E0. The higher energy state minus energy of higher energy state minus ground energy state. If it is absorbing a UV visible light, then that will be equal to delta E will be equal to mostly 35 to 71 kilocalorie per mole. And then considering vibration energy levels, if these energy levels are less energy than electronic energy levels, so for vibration is energy transfer between these vibration energy level is having to happen only by absorbing suitable wavelength. So this energy levels spacing, this vibration energy level spacing is 0.01 to 10 kilocalorie per mole. And when IR radiation is absorbed, this molecule will excited from one vibration energy level to another, and it vibrate with a higher amplitude. And then next energy level is the rotational energy levels. These energy levels are quantized and discrete. Spacing between energy levels are even smaller than these rotational energy levels, even smaller than the vibrational energy level. Okay, these are some basic idea. I know you all know more about these all things, so I am just to go through the basic idea. So I am not going to discuss more about this. Already you are known about these things. And next is the some law based upon this obeying this spectroscopy. That is first one is the Lambert's law. What is Lambert's law? When a monochromatic radiation is passed through a solution, the decrease in intensity of radiation with the thickness of solution is directly proportional to intensity of incident light. That is, the decrease in intensity of radiation with the thickness of solution is directly proportional to the intensity of the incident light. If some radiations are going through a solution, then what will happen? The intensity will decreases according to the thickness of that solution, and that is directly proportional to the intensity of incident light. Let's assume I be the intensity of radiation, the X be the thickness of the solution. Then what will can write that minus d minus di by dx is directly proportional to I. So we can put that in equality sign, then there will be a proportionality constant will come, minus di by ds is equal to k into I. Integrating the equation between the limit I is equal to I0 at x is equal to 0, that means I is equal to I at x is equal to 1. We get ln I by I0 is equal to minus k L minus k that ln is replacing 2.303 log I by I0 is equal to minus k by 2.303 into L log I0 by I is equal to A, that is known as absorbance, and k by 2.303 is equal to E, absorption coefficient. Absorption coefficient E is known as absorption coefficient. So A is equal to E into k by 203 is known as E. So A is equal to EI, that is Lambert's law. Beer's law says when a monochromatic radiation is passed through a solution, the intensity of radiation will decreases that with respect to the thickness of solution and is directly proportional to the intensity of radiation of light as well as the concentration of solution. Here it is in that the decrease in intensity of a radiation with respect to the thickness of solution is directly proportional to the intensity of incident light as well as the concentration of the solution. Let's assume I be the intensity of incident radiation and S be the thickness of the solution, C be the concentration of the solution. So we can written as minus di by dx directly proportional to the concentration of the solution into incident radiation. The proportionality sign we are changing. Then minus di by dx is equal to k dash into CI. Integrate the solution between the limit 0 to I to 0, I0 to I at x is equal to 0 and at x is equal to 1. We get ln I by I0 is equal to minus k into CL. 0 to S is equal to 0 to L. Okay. Sorry, it's not 1, it's L. So 2.303 log I0 by I is equal to Kc into L. So at last we can get A is equal to A in C into L. This is the Beer-Lambert's law. And A is the log I by I0. So T is the I by I0 or transmittance. We can say it as a transmittance. So log I by I0 is equal to A. Then that relation between transmittance and absorbance will be A is equal to minus log T. From the equation, it is seen that the absorbance, which is called optical density of solution in a container of fixed path, is directly proportional to concentration of the solution. Optical density of the solution in a container of fixed path length is directly proportional to concentration of the solution. What is A? Absorbance A is equal to log I0 by A. So T is equal to I by I0. So it will become the relation A is equal to minus log T. These all are the fundamental things. That is why I am going through the highly speed, and please go through the this video, and thank you very much.